In construction, the ancient Egyptians used three types of sand: dry sand, damp sand and reinforced sand. Now dry sand pours and acts like a liquid, and damp sand, when formed in a mould, keeps its shape. Reinforced sand can support heavy loads. Now in this experiment, the reinforced sand is made using hemp sacks. Successive layers of sand are sandwiched between the hemp. Now this method of construction is used today, known as mechanically stabilised earth, or MSE. And 3,500 years ago, the Sumerians under King Karagulzi erected a temple in Akkad in Mesopotamia. They used reed mats to stabilise the foundations and the brick walls. MSE was reinvented and then patented by French engineer Henri Vidal in 1963. Now, a single column of reinforced sand is strong enough to support a load of around 7 kilograms. The Egyptians used dry sand as a medium to lower the lids of a sarcophagus. The wooden stakes are positioned on top of the sand-filled channels. When sand is confined in this way, it can support huge loads. Today, small sandboxes are used to support falsework in modern bridge construction. The unique aspect of the falsework system enables the reuse of the trusses. In this experiment, a model of a sarcophagus was constructed using soy blocks. Sand was confined in the 4 compartments, and the cloth was used to block the hole at the bottom of each column. A small wooden table represents the load and stakes used in the sarcophagus. A load was placed on top of it, and I used flooring tiles weighing approximately 20 kilograms. Removing the cloth allowed the sand to escape. Now the sand acts like a type of hydraulic fluid, lowering the lid in a controlled manner. However, unlike a liquid, sand is not forced out of the hole at the bottom of the column. The load is held in position by when the escaping sand reaches its angle of repose. Now the angle of repose is when the sand stops flowing under its own weight, and for dry sand this is 34 degrees. To raise a load using sand, you need a special type of lever. A lever with 2 pivots. The load is placed between the 2 pivots. When the lever is forced down, the opposing pivot or fulcrum is raised up. A bearing plate is placed under the fulcrum, and it spreads the weight of the load over the sand. The object to be lifted is placed on a rounded beam. In this experiment, the roundness of the beam is accentuated. It's important to have a rounded beam because it turns rotating motion of the lever into a vertical lift, similar to a cam. To raise an object such as a statue, you need at least 3 levers. Position the levers evenly apart to distribute the weight and balance the load. Now to start, place the weights on the left side of the 2 outer levers. Then place a weight on the right side of the middle lever. This creates a type of V and prevents the load from sliding off. In this experiment, paper was used to gain height, replacing the sand. When the paper is packed tightly under all the pivots, the process can be repeated, and the lifting weights can be transferred to the opposite side of the lever. To raise a statue using sand, you would require a construction of a particular design, and several problems present themselves. How do you remove the levers once you've achieved the desired height? And 2, how do you support the statue once it's reached that height? And finally, how do you lower the statue to the required angle? The problem is solved by using compartments containing damp reinforced sand, constructed using bricks. Now the compartments sit either side of the lever, and the sand is self-supporting. The bricks are used purely to prevent the erosion from the elements. Now the damp sand is packed tightly into each compartment, and layers of matting are placed on top. A compartment of dry sand is used underneath the pivots. This compartment is made using timber beams. As with previous experiments, height is gained by pouring dry sand under the pivot, and blocks are placed on top of the first course, and the process is repeated. And once the statue reaches the desired height, the sand under the levers is removed. This is achieved by removing one of the beams at the base of the column, and as the dry sand pours out of the column, the statue sinks and comes to rest on top of the reinforced sand. Now enough space has been created for the levers to be removed. Now evidence to support this hypothesis can be found in the tomb of Rekhmire. It's called TT100. His tomb, or rather his chapel, is carved at the base of the hill. It's historically important for its pictorial quality, especially the text that adorn the walls. Now the south wall is very damaged but contains 4 registers dedicated to the work of construction. A register above the vizier reads, "Inspecting all the work in the field of Amun at Karnak and teaching his daily work to each man as part of his supervision of work." Now it depicts the construction of new buildings using brick and earth, making large statues and transporting stones and blocks needed by the river and by the land, and finally organising teams of workmen. Now there's a building being constructed that's difficult to imagine, but it's remarkably similar to the building needed to raise a statue. There is also a comment made by the worker described along the rising slope that seems to support this hypothesis. He says, "Bring the blocks, the earth, and bring a large number of mats, built by a dexterous man with his hands, lively in his task. Grant that the supervisors are men who listen and grasp the advice of the prince, who has experience in managing teams, who can provide the procedures to supervise, and who provides for us good quality food. He is our director, motivated by the desire that the king will last forever, and that he, the ruler of Upper and Lower Egypt, Menkaperry, may build a shrine to the gods so that in return they give him millions of years." Now the reference "bring the blocks and bring the earth and a large number of mats" is also shown on the wall of the building being constructed, indicated here next to the blue arrows. Now once the levers have been removed, the task of lowering can begin. To achieve an angle of 45 degrees, the statue must rotate about a pivot point. To do this, the bricks are removed from the top of the third column. An axle is inserted underneath the rear of the statue, and the brickwork can be dismantled. The reinforced sand holds up the weight of the statue. Then gradually, as the sand is removed, the statue is lowered into position.